Hey everyone, and welcome. Have you ever just looked up at the night sky and wondered, how does all of that stay up there? It's like this giant, perfect cosmic dance, and today we're going to figure out the steps.
So here's the central mystery. How in the world do you get 8 planets, some of them tiny and rocky, others these massive gas giants, all circling the same star without, just crashing into each other or flying off into deep space? It seems impossible, right? So how does it all work? Well, let's dive in and break it down.
All right, so the first thing you need to know to wrap your head around our solar system is that it's basically split into two completely different neighborhoods. Seriously, think of it like a big city, right? You've got the busy downtown core and then the sprawling suburbs way out on the edge.
So, in one neighborhood, you've got the inner planets. These are the small, rocky worlds all huddled up close to the sun. And then, way out in the suburbs, you have the outer planets, these enormous, gassy giants just hanging out much, much farther away. And honestly, they could not be more different from each other.
And when you really start to dig into the details, wow, the differences are they're striking. I mean, the inner planets, they're made of solid rock and metal, but the outer ones, mostly just gas. The inner planets are tiny in comparison. They don't have any rings, and they spin pretty slowly. But then you look at the outer giants, they are absolutely massive. Every single one of them has rings, and they spin incredibly fast. It's like two totally different kinds of worlds.
Okay, so we've got these two completely different families of planets living in the same system. So, what's the deal? What is this powerful invisible force that's holding all of them together?
I mean, it's a great question, isn't it? These planets are all moving at unbelievable speeds. So, what's stopping them from just shooting off in a straight line forever and just leaving our solar system completely behind?
Well, it turns out there's a two-part answer to that. First up is what you could call the big spin. Basically, the planets are still moving from all the momentum they got when the solar system first formed billions and billions of years ago. But that's only half the story. The second part is the sun's incredible gravity. It acts like this invisible string constantly pulling them inward and bending their straight path into a nice, stable orbit.
So the planets are moving, and the sun is pulling on them. But their movement isn't just random chaos. Not at all. It actually follows a very clear set of rules. You can think of them as the rules of the cosmic road, and they were figured out centuries ago.
All right, now for a long, long time, astronomers believed that the heavens had to be perfect. And to them, that meant planets must move in perfect circles. I mean, it sounds so neat and tidy, doesn't it? But is that what's actually happening out there?
Well, no. It turns out an astronomer named Johannes Kepler made this absolutely game-changing discovery. Planets travel in elliptical orbits. That just means they're oval-shaped. And here's the crucial part. Because the path is an oval, a planet's distance from the sun is always changing. Sometimes it's a little closer, and sometimes it's a little farther away. And this is where it gets really cool. The consequence of that oval-shaped path is another one of Kepler's famous laws. Planets actually speed up as they get closer to the sun, and they slow down as they move farther away. It's like this constant cosmic slingshot effect happening over and over and over again. Now, think about this. You've got all these planets moving at different speeds on these different oval-shaped paths. Because of all that, something really kind of strange can happen from our point of view here on Earth. It creates a pretty wild celestial optical illusion. And this illusion has a name. It's called retrograde motion. It's that moment when it looks like a planet in the sky just stops, starts moving backward for a little while, and then gets back on its normal path. But let me be clear, the planet isn't actually reversing. It's just a trick of perspective. It's all an illusion.
The easiest way to understand this is to picture a giant race truck, okay? So imagine Earth is the fast car, zipping along on the inside lane.
And then you've got a planet like Mars. Mars is like a slightly slower car on an outer lane. And it's slower simply because its orbit is so much bigger. It just has way more ground to cover. So what happens when Earth, our speedy little car, catches up to Mars and starts to overtake it on the outside? From our driver's seat, our perspective starts to change, right?
Exactly. As we fly by and lap Mars, our viewing angle makes it look like Mars is drifting backward against the backdrop of all those distant stars. It's the exact same thing you see when you pass a slower car on the highway. For a second, it looks like it's going backward relative to you. And that, my friends, is retrograde motion in a nutshell.
So we've seen how our solar system is organized into these two neighborhoods.
how it's all held together by the sun's gravity, and how everything follows these specific rules of motion. But all of this brings us to one final, really fascinating question about the future.
We tend to think of these orbits as being this perfect clockwork machine that will just run forever. But are they really stable forever? You know, scientists actually study something called orbital chaos, which suggests that over billions and billions of years, even the tiniest gravitational nudges from other planets could start to change things. It really makes you wonder, doesn't it? What will our solar system even look like a billion years from now?